Hey everyone, welcome back. So we are in the second question of this particular series. This is a coordinate geometry in a three-dimensional space question. Fine. And okay, so here a circle with diameter AB is given and the 3D coordinates of A and B is separately given. So what is the center of the circle is the question. The first part of the question, and we have to find radius in the next part, and then a cone-based question is just embedded in it. And we can first go for coordinates of center of the circle. So it's very simple. In this coordinate of the center of the circle, it's going to be, circle is a flat shape anyways, right? So it will be on one of the face of that three-dimensional space. And the midpoint formula is what we are going to apply. And it will lie in the midpoint of the diameter. So midpoint formula goes like this. Midpoint will act as center. Midpoint formula is just like an average. X1 plus X2 over 2. Y plus Y1 plus Y2 over 2. Z1 plus Z2 over 2. And now just substitution. So here we have, so I'm going to take in this way. 1 plus minus 3 over 2. 4 plus 2 over 2. 0 plus minus 4 over 2. That's simple. So 1 and it will go minus 3. 1 minus 3 is minus 2 over 2. 4 plus 2 is 6 over 2. Minus 4 over 2. Finally, we got this minus 1, 3, minus 2. This is the center of the circle. Minus 1, 3, minus 2. Okay. And next part is to find radius. Now we know the center, right? So this is a circle in a three-dimensional space like this. Is the center, this end point of the diameter, and this particular will act as a radius. So I know C and B or A, whichever easy, we can take that. I'm going to take C and A this way, so that A have like simple numbers, 1 and minus, no complications. So let's go with that. To find radius, apply distance formula for AC. So AC is equal to, what is the distance formula? Let me recall here. Distance between any 2 points in a 3D plane, it is going to be x2 minus x1 the whole square plus y2 minus y1 the whole square. The next third axis, z2 minus z1 the whole square. And here we go. Just substitute. I am going to use A and C. C is minus 1, 3, minus 2. Just now we found it, right? The center. And A is actually, it is 1, 4, 0. So it's square root of x2 minus x1. So I'm going to subtract in this way. 1 in a formula that is a minus, another minus, the whole square, plus y2 minus y1. 4 minus 3 the whole square, plus z2 minus 0. 0 minus minus 2 the whole square. And then let's solve for it. 1 minus of minus 1, this will become 2. 2 square is 4. 4 minus 3 is 1. 1 square is 4. And this is going to be 2 again. 2 square is 4. And it's root 9, simply 3 units. Radius is 3 units. That's simple. And next part. So that particular, the same circle, the center we know, and the end point of the diameter. So there is a cone formed in such a way with the vertex, and they have given this 90-degree marking. We have to find the exact volume of a cone. What is the exact volume of a cone formula? It's 1 by 3 pi r square h. So pi, you should not substitute 3.14 since we are just looking for exact value. And radius we need to find. It's just exact, not a decimal. And height is the only thing we need to find. But let's simplify this. 1 by 3 pi r square, which is 3 square h, right? And we can cancel out this 3. So we got 3 pi h. Okay, once you find the h, we will get the exact volume. Okay, now getting into the h. This is nothing but the height, right? The height, we are looking for the volume. And this I know. So it is just nothing but distance formula, right? The distance between B and C. C is actually -1, 3, -2, if I'm not wrong. Let's check it. Yeah, -1, 3, -2. So h is nothing but you apply the distance formula for VC. It's a three-dimensional thing. So let's use that. I'm directly using the same formula, -1. In a formula, there is a minus. C is also minus, so it will become +1, the whole square, right? Plus -1. In a formula, there will be a minus. Next coordinate is 3, the whole square. Then Z. 0 minus, again a minus comes, so +2, the whole square. It's simple. And it's a square root of this 0 square. I'm just not. Okay, let me put 0. And -1 -3 is -4. -4 square is 16. 2 square is 4, which is √20. We can simplify this as √5 times √4. √4 can be written as 2 √5. This is my height. So we just substitute that height over here. And we will get that value. It's 3 times 5 times 2 √5. And 3 times 2 is 6 pi √5 cubic units. This is the exact volume of the cone. That's simple. We have completed this. And a quick review on this. So first, circle endpoints are given in a 3-dimensional space. So the coordinates of the center of the circle is just nothing but the midpoint of the endpoints of the diameter. This is the formula. It's very similar to coordinate, just one extra slot for Z. And center we got. Then to find the radius, center to endpoint of the circle is counted as radius. So you can choose either AC or as I have chosen, or you can go with CB. Apply the distance formula. Distance is also very similar with the 2D coordinate geometry. After finding radius, then the third part is given like this. A cone with the same thing. The base is a circle. Whatever we solved before, the same thing will be here. And then to find the exact volume, we need h. And I connect the vertex and the center, then only it forms a height, vertical height. So to find that, we apply distance formula again for B and C. That's it. And you simplify and make sure it's not a rounded off value. It's an exact value. That's simple. So thank you so much for listening.